Welcome back to the Code Wolf. In today's video, we're going to explore how to use AI to query and chat with a NoSQL database. Now, a lot of people seemed really interested in another video I made about how to use AI to query a traditional relational SQL database, so I thought I'd create a matching tutorial for NoSQL DBs. However, when I researched what was already out there on this topic, I found a lot of the content to be overly complicated or overly long, or just full-size conference demo presentations with a ton of concepts. So the goal for this video is to try and demonstrate all those concepts as simply as possible in a really approachable way. We'll start with a quick demo of a completed NoSQL and AI-powered app and explore a few key concepts about how this overall architecture or app pipeline works. We'll also tour the really simple code base that implements all those concepts and see how to set up the supporting AI and database services. But enough talk, we've got our work cut out for us, so let's get started. A quick reminder to please hit the subscribe and like buttons to support the channel. It really helps out a lot. All right, so let's take a quick look at the sample app that we'll be working with throughout this video. This app is available on GitHub. I highly encourage you to clone it and take it even further on your own. The link is in the description, so check it out. Now, this app allows us to ask questions about monsters from Tears of the Kingdom, which was the big Zelda game from last year, one of the biggest games of the year, and I was a big fan of it. Now, our app is hooked up to a Cosmos DB Mongo DB database that currently has about 81 monsters loaded into it. So these monsters have a name and a description and a category, so there's some contextual information about these entries in our database. And this information is taken from a cool project called the Hyrule Compendium API, so I want to give a shout out there. So go ahead and check this out as well, but you don't need to pull this down for our sample app to work. So back in our app, let's just ask our database some questions, and we can do this with organic natural language. We don't have to write NoSQL queries or anything like that. So if I just say, tell me about some monsters, just something really general, let's hit submit and see what this comes up with. So this actually brings back quite a bit of information. So it says, here's a few monsters you might encounter, and then it starts listing them and providing information that it knows about them, such as the description or what type of items they'll drop and where they're located. It's kind of just dumping out a lot of information about different types of monsters. So it looks like it brought back about 5 entries. But I don't really want all of this information, so let's ask it something more specific. So we have a monster called a Lizalfos here. So I'll just say, what types of Lizalfos are there? Since it seems like there might be more than one type. And this response comes back really quick, and it says that there's 9 different types. So it's listing out the different options here, and this is just a really simplified list. Now, you'll notice that it understood this concept of types of Lizalfos. Even though the database doesn't really have a type column or anything like that, it just has a name and a description, it was still able to infer what we mean and contextually come up with a result. So let's try another one that might be even more impressive. So let's say, which monsters can use electricity? So this is kind of a general and specific question at the same time because it could be any monster, but they have to use electricity. So let's see what this comes up with. And if you notice, all of these are electricity themed. So this says that it's spell casting with lightning rods. This is engulfed in electricity and tends to explode. So it actually understood that we were asking about electricity, and then it went out and searched the descriptions and the names for anything that's relevant and kind of compiled this nice list for us. And again, it was able to figure all this out without any specific queries. We're just using natural language here. Now let's ask one last question to demonstrate another concept. So let's say, where is the Thunder Wizrobe located? So that's one of the monsters that it lists down here. And it sounds pretty cool, so let's find out where we can go see that in the game. And right away, it says that it can be found in Hyrule Field or Tabitha Frontier. And what's interesting about this is that this is a really specific question. So we asked a specific question, we got a specific answer. So there's kind of a spectrum here where you can ask open-ended questions with natural language, or you can ask for a really specific result, and either one of those will work for the most part. So you might be wondering how this is all working when we're not writing queries. Well, let's take a look at the app architecture and how this is set up. In order to understand the app architecture for our sample app, there's several AI concepts that we have to make sure that we really understand. And I'm going to keep this high level and as simple as possible. So the first three here are just kind of AI concepts 101. We of course have a prompt, which is our instructions, our context, or our query that we send to the AI to get a response back. So if you've ever used ChatGPT or any other AI app, whatever you type in and send, that's a prompt. Now, a completion is what comes back. So an AI can generate a completion in all kinds of ways, but when you get that response back in simplified terms, that's a completion. And of course, an AI model is a brain of sorts that's trained for certain tasks and goals. So, for example, GPT-4 is a general language and generative model that can do a lot of things. The DALL-E model is trained to generate images. There's the Ada model for generating embeddings, which we'll look at in a moment, and so on. Now, there's a couple other topics we want to talk about here that are sort of intermediate-ish level, but they're important for this app. So the first is an embedding. And I think a lot of people get too caught up in trying to understand all the nuances and details of embeddings. But basically, these are just numerical representations of real-world info that are used by AI to contextually understand stuff like humans do. And AI can help us create embeddings if we give it data. Now, these embeddings are usually represented as vectors. And don't worry, you don't need to know any math for this video or even to work with these AI services, but it is kind of important to understand what's going on behind the scenes here. So for our purposes, an embedding is usually represented by a vector, which is a list of floating point numbers. And the distance between these numbers in vector space determines the contextual similarity between them. So over on the right, we have all these different numbers, and this could represent a few words or a sentence or something, but the different parts of it are represented by these numbers, and depending on how far away these numbers are from other numbers and other vectors, there's all these comparisons going on, but it basically helps to produce mathematical similarities and context between data. And that's important because AI and databases really like vectors, and we can do all kinds of cool things with them. So the main thing that we're concerned with for vectors are vector searches. These allow you to search a database for contextually similar and related results using vector math. So we transform our data into these lists of numbers, and the database and AI are able to compare different sets of these numbers to understand how closely they're related. And that takes us to our main point here. If there's one thing to remember, it's just that creating embeddings for your data items makes them contextually searchable using fancy math. Our database and AI services can query and communicate using these vectors, and it all works out great for us. And we'll look at this more closely in a moment. All right, so with all these AI concepts in mind, let's take a look at a couple flows to demonstrate these concepts and walk through the code to understand how this app works. So on our homepage here, we essentially have two different flows to get this app working. And one is in the upper right, so we have this upload data button. And this launches a code workflow that populates our database with some NoSQL data and generates those embeddings. And then we have another button here to submit a search query. So let's walk through each of these to understand how this actually works. Now, I also want to mention that for this app to work, we do need a NoSQL database and our AI model set up. So over in Azure, I've created an Azure Cosmos DB for Mongo DB instance. And I'll include a little more information at the end of the video of how to set up these Azure services. But there's plenty of content on my channel that shows how to set up AI models and other Azure services, so you can check those out as well. So we also have two AI models deployed here, and one of them is an embedding model, so this is using the Ada model, and this is what will be used to generate those numerical representations of our queries and data, as we'll see in a moment. I also have a GPT-4 model here, and this is going to generate our chat completions and turn those results into a meaningful response for the user. Now, obviously I could have given this a better name, but I was just tinkering around and we'll keep this for now. So this test 4 deployment name, that's actually our chat GPT-4 model. So again, check out the end of the video or other resources on my channel for how to set up these Azure resources. We're also going to be using Azure Data Studio to browse our database. I really like this tool. I think it's very underrated. But enough about that. Let's go back to our app here a second. So when I click this upload data button, I have some breakpoints set up that we can use to walk through our code. So the first thing that this is going to do is pull from the monsters.json text file. So Let's close out all these other things and kind of clean up our IDE here. But if we open up this monsters.json, this is basically just an API response from that high-role compendium that I mentioned earlier. But we're going to take all those entries and load them into our database and vectorize them so that we can use them for vector searches. So I've tried to add comments here so that when you go through this on your own, it's clear of what's happening. So first, we just get all those entries in the monsters.json file, and we deserialize those into objects. So we're deserializing those into a list of monsters, so we have real C# types to work with. And the next thing we have to do is create a vector index in the database. Now this is the one step I'm not going to get into that much, but basically we just need an index in our database. If you're familiar with databases, they have all kinds of indexes, but these basically just help to improve data retrieval and similarity search. You just kind of want an index there if you want to be able to efficiently scan your database. So you can check out that method to see how that works, but it's not really that important to our higher level discussion or goals. So the next step here is the most important, and this is where we create database entries and an embedding for each of those items. And remember, we're kind of using embedding or vector interchangeably in this video, so this is going to vectorize or embed our data. So in our Mongo service, let's look at this create async method. And again, there's comments here so that we can understand what's going on. So the first thing we're going to do is that for each of these monster items, we're going to serialize those. So we're converting them back into JSON because that's what the AI model is going to want. So we kind of set up this embeddings request, and then we actually initiate that request. So on our OpenAI client, we call get embeddings async. And this is going to take each of those database entries as we loop through here and go out to our embedding model and get that list of numbers back that represents that data. Again, it's a numerical list that represents the contextual or semantic meaning of that data. So that's going to be our ADA model. And so our ADA model generates a response, and that includes our embedding on it, like I just mentioned. And we want to save both that embedding data as well as the original, more readable data into our database. So here we're combining that generated embedding and the original item, and then finally we just insert that into the Mongo database. So this create async method will be called for each of those, and it'll just populate our database. So that's going to loop through our entries after I clear out those breakpoints, and let's just give that a second to upload all of our entries. This actually runs pretty quickly, although it does have to go out and get an embedding for each of those items. There are ways to group this more efficiently, but I've kind of intentionally designed this just to be more approachable and simpler. So once that's finished, let's check out our database over in Azure Data Studio here. So I'll refresh this, and let's see if our collection comes in here. So let's give this a second to update and see what we get. And so that refreshed, and now let's look at our databases, and I just have this Wolf DB. But our code created this monsters collection. So MongoDB uses a collection system. They're very loosely like tables. I know they're not the same thing, but you can just think of it that way if you're not familiar with Mongo. And so if we go into this monsters collection here and we run our query, there's our 81 items. And you'll notice that there's this additional embedding property. So we have all of our normal data, but we also have those embeddings that we got from our ADA AI model. So remember, we sent out a request to the ADA model for each of those entries. It generated this long list of numbers, and these numbers are a semantic representation of the rest of the data. So that's kind of our first flow. If we go back to our app here, our upload process is complete. And that means we can now ask our app questions and run vector searches against that data. So for example, if I were to just say something like, tell me about some of the monsters, just something really general here, let's hit submit and see what this gives us. So this time we'll land on a breakpoint in our search method, and I've again added comments here so we can understand the flow. So the first thing we have to do is get an embedding for the user query this time. Remember, in the upload flow, we got an embedding for every item that we want to add to our database so that it can be vector searched. Well, that means we also have to convert our user queries into that same format so they can be searched against that vector data. So if we step through here, you can see we're again making this call to get embeddings async. And if we look at our response, there's going to be an embedding on that. So if we kind of just hunt through here and we go down to the embedding, There's our numbers. I know this might be hard to see, but this is a list of vector numbers. And then we'll be able to use that data to compare to our embeddings in the database. So if I were to keep stepping through here, now we can run this Mongo service.search method using that embedding that we got from the AI model. And so if we go down into that search method, you can see we're constructing a Mongo search query here and running that to get our relevant results back. Now, these Mongo search queries can be a little bit difficult to understand. I'm not going to get too deep into this, but I'll just point out a couple things about how this works. So we're using a pipeline search to run a vector query, and this accepts a few parameters. And the most important one is where we're passing in our embedding from the user query into this vector parameter. So this is kind of the vector that we want to use to search, and we give it a path to the property that we want to search against. And this K value represents the number of items to bring back, so it's going to bring back 10. But I don't want to get too caught up in the Mongo part, so let's just keep stepping through here. And you can see it actually brought back our 10 results. And so these are the database items that it thinks are semantically most close to the user's search. And the last step here is to just kind of clean up the search results that we give back. So we're removing the embedding in the image, because when we send that to our next step, to the AI that's going to generate a nice response for the user using this data, we don't want to include wasteful tokens or confusing data on that. So if we continue to step through here, eventually we'll end up back in our search method here. So let's just kind of skip past here. I'll click continue here. So at this point, we now have our vector search results, and we want to send those search results out to our GPT-4 AI model to generate a friendly response using that data. So we have this relevant monsters object. Remember, this is what we got back from our database. And so we're constructing a prompt here that says you're a helpful assistant, and we serialize that monster data into a JSON format that it will be able to read the structure from. GPT-4 is really good at reading structured data like that. And so down here, you can see we're sending it to the test4 AI model. So if we step through here, this response can take a moment since we're sending so much data out to the server. And since we're debugging here, Blazor server is trying to reconnect here. But let's just give that a second. And our response came back. And so if we look at this, we got our completion. And there we have it. There's our list of monsters that it's telling about, since we had a pretty general query here. And from here, we can start to do more specific questions. So we have a lot of different information here, and feel free to kind of search for whatever you're looking for. So again, if we were to say, what types of Lizalfos are there, since it's talking about that item here, if we submit, it's going to go through this process again. So it's going to turn that query into an embedding or vectorized data. It's going to use that vector data to run a vector search against our database and find contextually similar items. And then after it's found those items, it's going to send those out to our GPT-4 item to kind of scan through them and generate a friendly response here. And there it is. We have our different types of Lizalfos. So we have a more specific list here from our new query. So hopefully that gives you a good idea of how this app works. I encourage you to kind of clone this down and go through it yourself. And I've included that data with it. So as long as you have the Azure resources and AI model deployed, you should be good to go. You're also going to want to update your app settings here to include your AI endpoints and keys and your Mongo DB connection strings and keys. Obviously, these are secure, so I'll be deleting these resources right after this, but make sure you fill those in. And that's just how the general flow of this app works. Now, there's obviously ways we could improve the performance and make this more efficient, but I've kind of designed this to be as simple as possible to step through those key steps and give you a starting point to build off of as you experiment. Now, I promised I'd give kind of a quick overview of how these Azure resources are set up. So to create the Mongo DB database, you'll just want to go to Azure Cosmos DB. So search for this in the portal or wherever you want to create it. You can also use the CLI or other tools, but just as an example here, you'll go to your Azure Cosmos DB page and click Create. And then you want to make sure that you choose Azure Cosmos DB for MongoDB. Now, technically, you could accomplish this solution using other APIs here, such as NoSQL if you use the search service with it. But I like Mongo for this example because it has strong vector support built in. And so let's click Create here. And then you'll also need to use the vCore cluster. And so let's click Create. And the rest of this is mostly self-explanatory, so I'll just point out a few things here. One is that for this cluster tier, when you click configure, be careful, these costs can add up fast. And you will need at least the M40 tier if you want to do the more advanced HNSW, I think the acronym is, that type of vector search. But you can also do the IVF search, I think it's called, on the 30 tier or lower. So just kind of look into that yourself and figure out which of those tiers you want to use. Again, I'm referring to this vector search here. So depending on what your Cosmos setup is, you can do different types of searches and indexing. Now, the other service here that you'll need is the Azure OpenAI models. And for this, you can just go to Azure AI Services and create an OpenAI account. So we'll say create. And this is, again, fairly self-explanatory. Again, be careful with the pricing. I'm using a serverless model that doesn't charge you unless you're actively querying with tokens. So this standard S0 should work pretty well for this scenario. And you'll just go through this process and create that. And after you create your OpenAI service, so let's look at our service here. Remember that your model deployments are managed here, and this is going to link you out to Azure OpenAI Studio. And then from here, you can click on this Create New Deployment and pick your model. So again, you'll probably want to use GPT-35 or 4 for your chat completions. And you'll want to use an embedding model like Ada002 for generating your embeddings and handling all of the vectorizing of your data. One last thing I want to touch on to try and further help understand these concepts, I've included a couple diagrams with the app that I created. So the first one is just that upload flow where we vectorize the data. So we add a new item and send that item data to our AI model and save that to the NoSQL database with the original data. So just feel free to look through this if you want more of a visual representation of that. And then I'll also include one of the search flow, which is a little more complicated, but still not too bad. So the user query gets sent out to the Ada model to generate an embedding, and we use that embedding to run it against the NoSQL database. And then we send those search results to the GPT-4 model that generates a nice response back to the user. So that's a really quick overview as a visual here, and I'll try to include these in the sample app as well. So thanks so much for watching. Please hit the subscribe and like buttons if you found this helpful, and I'll see you next time right here on the Code Wolf.